where they are for now, but I will figure out kind of where I'm looking at them. Okay, but for now, enjoy. Anybody else have sign guidelines for me? A lot of you already did this. If you did not, please get them to me in the next couple of days, okay? Let's get that homework out. And yes, anybody that chose the number after 66, they were smaller on there. Okay. Yeah, original. Okay, so here we go. As we move into 1.3, okay, I realized yesterday, not super exciting. There's a couple things in chapter 1 that aren't going to be super exciting, but we talked about those terms yesterday. We're going to use them all year, those undefined terms. So terminology is a large part of geometry, so if you're like, geez, why do I need to know this? You kind of need to know the things word for word, okay? And I wanted to see how we are getting with this stuff as we work through, okay? Okay, in general, how did our first section go here, 1 through 5 yesterday? Good, not good? I tried to prep you yesterday. This is where I got real, like, are you kidding me looks from you yesterday. I tried to prep you for this line right here. Okay, so let's look at each of them. The intersection of CM and RM, notice they used line notation. That should have been fine. Name 3 collinear points. You had several options. I just gave a couple of choices. You should not have included V. V is not a point. V is the name of the plane. Okay? 2 other ways to name plane V. Any 3 non-collinear points. I did not feel like listing them all, so I only gave a couple of options. So one option I gave was C and X. They are not collinear. These are collinear, these are collinear, but all 3 of them are not. Okay? Cool. Now I want to talk about number 4. Are points R, N, M, and X coplanar? They're not. Question, where is point R? Point. Yes, good job. Up here. Okay? If you're visualizing this thing, which you're going to hear so much in chapter 1, the plane is flat, R is above. That's why they drew that line. In theory, I guess there could be a point down here. We could call it sigma. See? It's not as exciting. Your number after 66 will also be less exciting at some point in your life. Okay? Where would you say this is? Not above, but actually down. Okay? So hopefully that was okay. I tried to prep you for that thing coming. Okay? How did our never, sometimes, always questions go? Good? Okay, I'm going to hit the ones from class yesterday as well. Now in general, this is just a mathematics thing. Forget the class you're taking. Always means I can't disprove it. Sometimes means if I can disprove it even once, it's not always, and never means I can never make it work. Okay? These are never the same ray. We talked about it. They don't have the same endpoint. So that one should have been okay. This might have thrown you for a loop. You might have said x, y, and x, z are always opposite rays. Here's my counter example. Are those opposite rays? Because opposite rays are supposed to form a line, and these do not. That's your counter example. A plane does not only contain 3 points because it contains an infinite amount of points. Okay, so it can't just be 3. 3 is how you name it. 3 non-collinear points are contained only in one plane. That was the definition that we gave yesterday. If a line lies in the plane, then one of the points is on it. Well, that's easy. Okay, the last one. If 3 points are coplanar, they are collinear. That could be true, but it doesn't have to be true. So yesterday, I gave you these. I didn't go over them with you. So can you flip back to these? These are sometimes, always, or never questions. Have a quick conversation with somebody. This is in the classwork from yesterday. Okay, talk about what you think they should be. Always, sometimes, or never. Remind yourselves of what your answers are. Okay. Now, be ready. So we're going to stand. And remember, you might not agree with other people, but now that you've seen these things for another day, maybe you have a different response, okay? So intersecting lines are, I want you to stand up when I say your choice. Okay, intersecting lines are always coplanar, up for always, up for sometimes, up for never. Intersecting lines have to be in the same plane. I can't have a line against the wall intersecting with another line. Like if you extend this, there's no way it intersects that. They're in different planes. If they do intersect, they have to be in the same plane. That is always. Good job. Okay, two planes are up for never, intersecting exactly the same. Good, everybody. Nice job. Okay. That was actually in the homework. There's the one person that tried to prove it, okay? 3 points, this time we'll do hands, okay? 3 points are hands up for always coplanar. Hands up for sometimes coplanar. Hands up for never. It's a postulate. It's a postulate. Through any 3 points, you can draw a plane. That was actually one of the last postulates that we did yesterday. It was an axiom. Okay? A plane containing 2 points of a line. Put your head down. Don't slam it down. That seems concussions. Head down for a plane containing 2 points of a line. Never contain the entire line. Head down for sometimes contain the entire line. And head down for always contain the entire line. Some of you didn't understand the activity. Your head was not supposed to be down the whole time. You put your head down when I say your response. Ha! Survey says always. If you have 2 points of the line, you have the entire line. Because remember, planes go on infinitely in both directions. Last couple I'll just show you. 4 points are, let's all just say our response. 3, 2, 1. Good. We gave that example from the homework. You can have 3 points and the 4th point can be above or below, so they don't have to be, although they can. And 2 lines, I hate this one. I hate that. Because in theory, I hate this. There are certain things in math I just hate. What if they're the same line, they're intersecting infinitely many times? I don't like the person that's like, well, technically. I actually didn't like sometimes. I said never. Because I don't buy well, they're the same line, they just, no, I don't buy that. Okay, so don't worry about that one. Rest should be good. Okay? This one right here, I'll bet somebody was thinking yesterday, I'll bet I can get a plane to intersect at just 1 point. That drawing that they drew, this defeats it. Since planes continue infinitely in all directions, they're going to meet here. So it's not just that point. They'll meet over here, okay, or over here. It's a nice try, but it doesn't quite work. Okay? The rest of this should have been fine. Okay? So let's go to 1.3. 1.3 is a little quicker, which is good. Okay, like I said, we're really just setting stuff up. We're going to talk about measuring today. Okay, nothing too extravagant. I don't know if anybody has been doing this. Period 5 has. Occasionally, when you've had time, has anybody just been messing around with their compass just for fun? You should, okay? We're going to start drawing with the compass. If you mess around with it and play around with it, that's going to help, okay? I've actually seen people submit homework with drawings of circles on it. Okay? What? The compass is the circular tool. Hold it up proud. Okay? That's your compass, okay? Cool. All right. Let's see. I want you to. Okay. Do the entire front page as a group. The entire first page as a group. Each question, all of them. Let's go. We have Shang Fei joining the group.
Shang Fei's in my sister's math class.
What?
Not Shang Fei's in my quiz.
I asked him to get me the roster because I probably talked for this all. You're doing the whole page, not just the first 2 questions. You're doing all of them.
My sister's math. She said she
That's the most classic.
And then she asked me, and he said no, but then he came to school and I saw him, I said, it's chick big, and oh yeah,
I saw some at lunch duty that said, how's it going? He goes, it's great. I learned something new every single day. That's what I'm saying. Yeah, I want to find out who else is in that class, because I probably taught all of them.
I think it's calculus, I don't know.
It is. Did we say no, yes, no for the top section?
Yeah.
Good. Those third ones will not. They're in different planes. Fun fact, does anybody know what those lines are called? I actually said it one time last year. Lines that look like they're going to intersect, but actually they're in different planes, so they'll never touch. Somebody usually guesses a letter at this point.
R.
A is out. No.
R.
R is out. E. So
Y.
I don't remember how to draw the hangman at this point. I'm just going to draw this.
Y.
L is out. Y is out. Z is out.
X.
Okay, you all lost. It's called they're called skew lines. If you're like, I don't remember that, I said it one time, that's it, okay? You got about 30 seconds to finish that front page. If you finished it already, great. If not, kick it into high gear. Maybe a minute. Full first page, including the ones at the bottom. Skew lines.
I don't see a point at.
Okay. We about good? Yay, nay, whatever, yay? Yay. Okay. This next section, okay, remember, okay, there's a matter of preference when naming faces or naming the plane. So for the bottom, I just called it plane ABC. 3 letters are required. If you want to list all 4, you can. Some people will do A, B, C, D. It just makes them feel better, which is like fine. But as long as you have any 3 of them, that's going to constitute the whole plane. So at the top, I did plane E, F, G, but I also could have included H. Okay, so as you look at mine very quickly, as long as you have 3 of those letters in any order, you're fine. If you really want to just make sure you're clear, just do all 4. Just do all 4. Okay, cool. The drawings were not supposed to be complicated. If you're like, is this a trick question? No, I was like literally just looking for stuff like this. I was not looking for anything complicated. There are no trick questions. Okay, that's all. You probably drew this and you're like, is that all he wants? The answer is, yeah, okay. And then this one, we're really just making sure that we know whether it's one endpoint or multiple endpoints, but it's endpoints, line, or points. So array has one endpoint. Now I like to think of array as a point and a line in the other direction, but it's not a line. You just can't view it that way. Now a line has infinitely many points. A segment has 2 endpoints, good, and a segment is part of a line. Okay, good. So when I tell you, you're probably not going to find today too bad. I really mean that. There's hit and miss. There's days where it's a little bit more involved and days where it shouldn't be too bad. There's your heart. There's your solving algebra 1. Solve it. I know. Remember, put a heart by it. Put a heart by it. Anything algebra 1, we love. You could probably just like double tap it and put the heart by it, right? Just do this. X equals 7. Yes, you should have been able to get there in that time. I can say this because I watched you do this like very, very quickly. Distribute that negative sign, combine like terms. So when you go throughout the year, you're going to wonder, how much algebra do I need for geometry? Enough, but not as much as last year. That being said, I wouldn't even call this algebra. I would call this pre-algebra. Okay, cool. We can skip the fish question. Okay, next postulate, the ruler postulate. It sounds like something you would actually show to kindergartners. Anybody want to read the ruler postulate to us? Instead of me talking? Somebody? Cece.
Points of a line can be put into one-to-one correspondence with their real numbers, so that the distance between any 2 points is the absolute value of the difference of the corresponding numbers.
Okay, so this is essentially telling you something you've known for a couple years. You can find distance using absolute value, whether it be on a ruler or just on a straight number line. Okay? And in fact, so if I were to line this ruler up right here, this is line segment AB. That's why it's a segment. I want you to notice this is again part of the quirkiness of the notation in geometry. Do you see how this AB is italicized? Do you know about italics? Okay, that's actually not a mistake. Sometimes we format things because we feel like it. Sometimes we do it because it's the right math. For example, when you're with Miss James, I know when you did geometry, I know she definitely didn't just let you swap out these. Does anybody remember the difference between them? Yeah? Should we get her? You want to go get her?
Yeah.
Should we go get her? Yes. All right, we can get her. Because none of you apparently remember. So how many of you are in here, like 30, and not one of you, you just wanted to see Miss James, didn't you?
Yeah.
That's fine. Okay. Hey, it's Miss James!
Oh my gosh, there's so many people in here.
You said that the other day. It's the same group anyway. We were talking about notation, and I said when you denote lengths of segments in geometry, they need to be italicized. And I said that's not a if you feel like it. That's the way it always goes. And I said, Miss James had that too. She definitely didn't let you just slide on the difference between capital B and lowercase b. And all 30 of them, no one remembered the difference.
She remembered.
Who remembered and they lied because they wanted to waste time and bring Miss James over? Okay, that's what I
Are
thought
you
I said.
kidding me? The little B versus the big B? Are you serious? Look at them just looking at it.
What is the difference, Kennedy?
It's like, well, the big B is like the height of like the entire 3D figure, and then the little B.
Actually, that's not it, but thanks for
B
playing.
is the height. That's
for playing.
great.
I love getting Miss James all wound up, okay? Caleb?
B is the area of the entire base of the figure,
Which B?
the big B.
Big B. Ah, base area and then actual.
Oh, mamma mia.
There you go, right there. Okay, good job. Miss James, everybody.
Although I didn't realize, I'll be honest, I didn't realize that you had to italicize. I mean, I knew about putting the line over it for line segment, but
Italicize is length. How about that? Okay. That's actually the length right there. Please jot it down. Okay, absolute value of A minus D.
look at Mr. Jutel rocking the geometry.
Yeah, they
Woohoo!
didn't think they'd be back, but they're back. It's fun to just get Miss James all riled up, isn't it?
Yep.
It was fun 2 years ago. It's actually fun for me as an adult. Okay, so we're back. Okay, so I can find the length of any segment by doing the absolute value of A minus B. That's actually the same thing you've been doing for a couple of years, okay? So look at some of these. You're gonna laugh at some of these questions. You're gonna be like, are they this easy? Yes, but the notation will get you. So if I wanna find, I don't know, do you like my line segments of the dog?
That's interesting.
It is interesting. That's what I thought too. Okay? So if I did this to you and you had to find, notice, the italicized nature of A, B, and BE, you might just say, wait a minute, am I just finding this distance like I'm in 5th grade or 4th grade? The answer is yes, but they changed just a little bit. I don't know if anybody noticed the scale. It's not by ones. Anybody knows the scale? 3. So does anybody know the length of AB? This is not a trick question.
9.
Okay, apparently it is a trick question. 9. Okay. 9. Okay. Now I'm not suggesting any of you would do this way. Most of you would find the scale of 3, and then you would say 3, okay, 6, 9. That's what you would probably do, and that's fine. What they're telling you is, where's the location? 9, 12. Isn't this negative 15? So then 18, 21, 24. They're telling you in the last one, you actually could find the distance by doing the absolute value, and then this would become negative 9, and this is 9. Now I'm telling you, I don't think you should do it that way, but you could. Okay, but you could. What about BE? I could do it the same way, or in theory, I could just count. How long is BE? Somebody probably has it. Okay. So BE is equal to 21. Good. Okay, not a trick. Okay, but they like to throw a couple of algebraic type questions at you. So your next postulate, remember, you don't have to memorize the postulates, but you should know that they're true, because postulates you don't have to prove. Eventually you'll have to prove stuff. If 3 points A, B, and C are collinear, and B is in between A and C, so let's imagine this. They're collinear, so I've got A, I've got B, and somewhere here I've got C. This is called the segment addition postulate. That should not surprise you. AB plus BC is equal to the length of the entire thing. What does this look like as a picture? Look at this. You don't need to jot down the picture, I need you to look at it. Again, grade school stuff, but pretty soon, like in a few minutes, we're going to mix grade school stuff with algebra kind of stuff, and you can see where they all connect. Now I could actually manipulate this any way I want. It is a fact family. I also want you to notice these are italicized. I could manipulate this however I want. That means AC, I could do AC minus BC, and that should be AB, but you get the idea, you get the gist. Okay? Cool. So given points A, B, and C are collinear, B is in between A and C. I drew a diagram. Complete each equation. If AB is 5 and BC is 4, easiest question of the day, what is AC? You're like, look at us. We're taking an accelerated class. Just stay tuned, okay? If AC is 12, so this time the entire thing is 12, and BC is 7, what should A be?
5.
Should be 5, which actually already was. Okay? Cool. Now, I want you to work on this question as a group. Find the value of x, and then find EF as well as FG. Jack, how long have you done this? You just your last history? Not going with that. That's what I was concerned. It is stressful.
I was like, I swore
Make sure you find EF and FG as well. Don't just find X. Don't just find X. Find both segments as well.
oh yeah.
Okay, now, again, just quick glance. A number of you did find X, but you didn't finish the problem. That's going to cost you a lot in this course. They want the value of X, and they want the value of everything else. Here's the good news. Everything lines up when you plug it in, okay? So what equation can I start with? Anybody? Who's just got the starting equation? The starting equation. Ryan?
4x minus 20 plus 2x plus 30 equals 190.
Yep. Okay, now I put parentheses around. That's not required. I've watched you do enough algebra at this point. I would like to see this. Okay, you combine your like terms, you solve, you should get x to be 30. But again, if you stop there, that's a silly way to lose points. You did the hard work. You have to plug each of them in. Okay, and once you plug each of them in, what's this guy become?
90.
So EF is, did I hear 90? Okay. And then that one should be, if I plug it in, it should be 100, and then they combine to get 190. I don't anticipate you ever struggling with these, but still, okay, they kind of run into problems from there. Okay, sound good? Cool. Okay. How many of you have heard of this term before, congruent? Just ever. We don't use it very much in algebra. You're going to use it a lot. You got to get used to drawing the little symbol too. So when you have congruent segments, I'm not sure if you've ever drawn it, but get used to it. It's this little squiggle with the equal sign. These are two segments with the same length. It's a term we usually use specifically in geometry. We don't use it very much in other courses, although they might show it. Or you might have a math teacher, like listen to Miss Galbraith last year. She just used it a whole bunch, even if we weren't defining it. Fancy word for they have the same length. So these are congruent segments. A lot of times we mark it with just this one tick mark. Okay, that means this is congruent to this. Okay? And if the length of AB is equal to the length of CD, here's where the notation will get you. It's why I'm yapping at you so much. You wouldn't just say this. You would say segment AB is congruent to segment CD. This means the length of AB equals the length of CD. This means they're congruent, okay, and the notation will matter. Lengths are equal, segments are congruent. Might be a note you jot down, because it gets messed up a lot. Lengths are equal, segments are congruent. So you actually wouldn't write this. AB is congruent to CD. That's actually wrong. That says the length of AB is congruent to the length of CD. Lengths are equal. Segments are congruent. You get used to it. Okay, it's one of the more annoying parts, but that's how we start out chapter 1. So is AB congruent to DE? Give me a thumb up if you think it is. Thumb down if you think it's not. Is AB congruent to DE? Can't see some of your thumbs over here. Sari, why not?
Because AB is longer than,
How long is AB? Do you have that?
no, I don't.
Well, it goes from -2 to 3, so I bet you can figure it out right now. It's 5, okay? And the length of DE, we show on that one, 4, so they're not congruent. Okay? Good. Okay, last part, I told you today's fairly short, is a midpoint. A midpoint is any point, last I finished the day, is a point that divides a segment into two congruent segments. You not doing that? That'd be awesome. Thank you. Midpoint formula actually is something we'll use quite a bit. We use it a lot next week. But a midpoint is the exact halfway, and it means you divide exactly into two congruent segments. So if this was the midpoint, this segment is congruent to that, which means the length of that is equal to the length of that. Okay? A midpoint, or any line, ray, or other segment through the midpoint, is said to, I wonder if you've ever heard this word before. When it cuts something in half, there's a word for it. Okay, to two equal parts. Bisect, nice job. So to bisect the segment. Good. Okay, so in this particular spot, hey, if B is the midpoint, it bisects it, so AB is congruent to BC. Okay, is what we're saying. Or in any regard, you bisect it. So going back, this line bisects that whole segment, so this is congruent to this. It's just kind of terminology. Okay, cool. All right, work on this question. M is the midpoint of RT. Find RM, MT, and RT, which means you got to find X as well. Just you though. No group work on this one. Let's see what you do. M is the midpoint of RT. Make sure you find all of them. Find X, find each one. I think I also want the entire thing. These are one all parts. One RM, MT, RT. That helps, practice helps. Because M is the midpoint, it bisects, which means what is the only thing I need to do with these two segments? Ronan, what do I need to do with them?
Set them equal to each other.
Yeah. Okay. So 5x plus 9 is equal to 8x minus 36. You will notice none of the algebra is very taxing here. You just need to know what to do with it. Okay? Moxie, what'd you get for x?
X was 15.
Okay, but again, I look, it is very silly to do this correct and then lose points because you don't finish the problem. Especially because everything lines up really nice. It's very pleasing when I look at the answer and I know it has to be right. If x is 15, then what is Rn? If I plug in 15 for Rn, what do I get? Is it 84? Well, MT should also be 84, but when I plug it in, it definitely works. And then what's the length of the entire segment? RT is, yeah. So it's not just that you're required to do this. It's very nice that it lines up rather than doing like a check step. Okay? Cool. Okay, I got one more question for you to do that I think is kind of tricky that you're going to work through, but let's just do this part. It says circle the expression that relates the coordinates of the midpoint to the coordinates of the endpoints. I want you to look at those and make a decision, and then you'll work on the last question on there together afterwards. I want to know the coordinates of the midpoint related to the coordinates of the two endpoints. Okay, now the line is there if you need to like look at one and think about it. Like it would be pretty easy for me to pick like -2 and 2 and know what the endpoint is. Okay, so make your choice. Either this relates to the midpoint, this relates to the midpoint, or that. I'm pretty sure there's one we can toss out fast, but you never know. Okay. Let's go stand up if you like this one. Oh, thank goodness. Okay, that was not going to get you anywhere. Okay, stand up if you like this one. Stand up if you like this one. Was anybody going to stand up for the third one and then they decided not to because everybody stood up for the second one? Come on, be honest. No?
I just didn't finish.
Yeah. I can't take that long. Okay, this one makes no sense at all. Nothing. It's very natural to think that you would subtract them because you subtract for distance, but it wouldn't work. If I did 2 minus -2, that's 4, slice it in half, that's 2. That would never, ever work. If I choose a really easy example, if I do -2 and 2, -2 plus 2 over 0, what is that?
0.
Okay, well, yeah, not over 0, over 2. Yikes, 0 over 2, which is 0, which is my endpoint. Okay, so you actually add them and slice in half or take the average of them. Okay, the last question you're going to work on, I want you to talk about it. I want you to think of all possibilities. Okay, the question's spelled out there, read it together. Try to come up with all possibilities. Go for it. Come on. Read that problem together too, don't you get yourself into it. There's a couple options. Anybody see the new Notability logo? It's heinous. It's so ugly. Oh, what did they do?
It was better when I was bored. Now it's just like big.
It's disgusting. Also, it looks like the pencil's like bleeding on the ground. Like, what is
Wait,
this?
wait, hold on a second.
No, I don't even want you. I'm not comfortable. I'm not validating it. Yes, there is more than one answer, and I want you to try and find all of them.
It's just the opposite.
I'm not ready. Yeah, because they do actually that.
No, it's
Try to find all the combinations. There's not like 100 of them. There's a couple. There's just a couple. There's a couple. Not gonna play that game. Love that game though. Love that game. Anybody figure out how many options there are?
I got one answer.
Huh?
I got one answer.
Two, 4. Any other guesses? 3?
Oh wait, what are the possible coordinates? It's not the space in between. It's not like.
Okay, let's start going through and we can see there's definitely more than 2 options.
There's 4.
Okay, good. Well, good news. X is at 0. 0 X's, the way that you should live your life, okay? Nothing. First of the year. X, Y is 4. What's the most natural place to put it, in my opinion? Right here? Okay. Well, if X, Y is 4 and X, Z is 9, one option could be to just put them all here. That's probably the first option, first one I did. That's what I expect a lot of you to do, okay? But if that's the case, what are the possible coordinates of the midpoint of YZ? So one option for the midpoint, what would it be of YZ right there, between 4 and 9? 6.5, okay? We like option 1? Yeah, okay? Well, the next natural thing to do is to just do the opposite. So if X is 0, I could have put Y here, which would mean I would probably put Y where, or Z here, yeah? And then what's the other option? Okay. A lot of times people get these and then they stop. Can somebody tell me why there's more options than just those 2? Okay, Kim?
Because you can like mix and match the negative and positive points.
Can we not make that sound right? That would be great. We mean mix and match. I like that.
Like you can like instead of just taking the positive 4 and the positive 9 and the negative 4 and the negative 9, you can use the negative 4 and the positive 9.
Yeah.
Or
I like that. I like mix and match. That's a good way to put it. Okay. I can make X, Y 4, but what is the qualifier? Okay, what's supposed to happen? XZ is supposed to be 9. So instead of just using this 4 with this 9, I could use 4 and then use on the other side and then maintain. So I don't know if anybody found the other points. Anybody find the other 2 midpoints if you do that? Okay, Jazzy? You can get 2.5. You can also get negative 2.5 if you quote, I like that, mix and match, knowing that X has to be at 0. Okay? So it's just more of an exercise in thinking a little bit. Okay? Please spend the rest of the time, get jump on this. You got about 20-ish minutes. Make sure it gets checked. And continue to practice circles. If you need questions about circles, ask Conlon because he's really good at it. Probably not. What? Yeah. I thought you meant like ever again. I'm like, Andy, what are you doing? Hey, just sit tight. I'll give it to you.
yeah, you said you did 2, 3, 5, 6. I think 5, 1, 4, 2, 5, 3, 6. I want to hear it.
Eddie, I got scared there. I thought you meant like I just might not end up coming. Monday. Or Tuesday, because we're not here Monday. Tuesday, there's no answer. You are off on Monday. Don't worry. I just want people to mess around. I haven't shown anybody how.
Made a whole circle pattern.
I haven't showed anybody how to do it. I just want people to play around with it. You can also use one of mine from the back if you want, and see if you like those ones better.
I like trying every time I try